Hello and welcome to IT Security Labs, and this is a continuation of our lab where we are building an Infosec lab for learning cybersecurity skills. And in this video we're covering the basics, one of the most important things that we should be covering, which is DNS and DHCP. I'm going to show you how to configure DNS and DHCP and also explain why these two protocols are very important for cybersecurity. If you're brand new to this channel, we are building an Infosec lab and this is a video number 9. You work for Trevor Phillips Industry and this company wants you to set up a DNS and DHCP server on a Windows server and make sure that you can control these two critical services. So you may be wondering, why should we care about these two protocols, DNS and DHCP? We should just learn about cybersecurity, right? Well, these two protocols are very critical for anyone who is responsible for securing an environment. If you care about security, these might be the two most important protocols that can really cripple your environment. For example, why is DNS important? DNS actually works as a name resolution protocol. So when you try to reach facebook.com, DNS is what knows what IP address facebook.com resides on, or what block of IP addresses, whatever they're using. So DNS is really what makes the internet work. And if you communicate with a lot of network administrators or system administrators, they will tell you that most of the time when they have issues, they are likely to blame DNS, and when DNS goes down, it really is bad for everyone. So you can imagine attackers really like this protocol. If there's a protocol that you can take down and bring things down, that's something that they might be interested in. So you may see that people can have all these kind of DNS attacks that I listed here. For example, you can have people flooding your DNS server, making sure that your name resolution doesn't work, so they can attack your internal DNS servers, so your internal clients cannot access the internet, resulting in your company losing money. They're gonna attack the actual protocol itself. They can bind what is called DNS binding. People can hijack a domain name. So our company's name is Trevor Phillips Industries. If we don't configure our DNS correctly, or if somebody can take over what Trevor Phillips Industries is, tpi.com, for example, they might be able to redirect our traffic to another site that is hosting malicious content, so all of our clients will be redirected there. That's why you really need to have a good grasp on how DNS works and how to configure it, which is what we're going to be doing here. And next to that is DHCP. You see, DHCP is what the host, when you connect your computer on the network and it automatically gets an IP address, there's a process that it goes through where it asks for an IP address. And a server is going to say, yes, I will give you an IP address. And that's a DHCP server. And as you can imagine, the DHCP server is going to give any machine information like, here is your IP address. Here is where you can find your DNS servers, which we just spoke about how important DNS is. And here is your identity. And attackers love to hijack DHCP because they can poison what is called a DNS poisoning attack, when they can just, instead of forwarding your clients to the right DNS server, they will use DHCP and point it to a different one. So your clients will be sending their requests somewhere and people will be able to see what kind of requests they are and even send false information to your clients. We can do what is called a DHCP starvation. This one is a simple one to set up in your Kali Linux, where an attacker, once they get a hold of your network, they'll just request a bunch of IP addresses until your server runs out of IP addresses. You're going to see during the setup here that when you set up a DNS server and a DHCP server, the DHCP component is going to have a limited amount of IP addresses. It's a limited number of IP addresses, unless if you have multiple VLANs and segments and all that stuff. Then an attacker can just have an entirely rogue DHCP server that might be handing out IP addresses that don't even work at all, resulting in all your clients not working. So there are these attacks that are out there. That's why we're going to be setting this lab, and I wanted to spend some time explaining these before we just jump into just configuring. So that's why you should know about it. It's not redundant. It's very important information. All right, so now let's go and access our ESXi, and we have to put a certificate to resolve that error. But for now, we're not doing that. Here are our machines. We want our DC. Let's go ahead and start it. All right, so here's our domain controller. I'm accessing it through the web by just going to console, opening in a new tab, and it's through the web right now. And we can now type our password. As you can see, it's already joined to itself as the domain controller. So our domain is tpi.local, TrevorPhillipsIndustries.local. That's what we'll be resolving here in our domain. So let's keep that in mind. And when you get in here, you're going to see that it will start a bunch of other services like server manager. So let's give it a minute here. All right, so as you can see here, we're inside our server and here's server manager. What we need to do is add roles and features. I'm going to add both DNS and DHCP at the same time. Then we can just configure them. It doesn't take a long time actually to do this. So say next. And role based, that's okay. And here's our IP address for the server. And we just say next. So DNS server is already installed. If you don't have it, just check this box here. So you make sure that your DNS is installed. Then also check the DHCP server. Then this time we'll actually then go ahead and configure both of these services. DNS was forced for us when we promoted this machine to a domain controller, but that's okay. But for now, let's go ahead and do that. Then next, here's our DHCP server. Do you need to specify alternative source path? I don't know what they're talking about. So we just install. We don't have any alternative source path there. So this is we install our DHCP server. All right, so to save us some time, while it's doing the DHCP installation, let's go ahead and configure our DNS. There are two places you can go. You can go here to access your DNS service and configure it this way, and then right click here and go to DNS manager, or you can go to the manage tools, but this is the easiest one. Now we are in the DNS manager by just right clicking on the center one, and it says it's TrevorPhillipsIndustries.local. So let's check it out and make sure that it's working. We are interested in looking at our zones. Let's look at our reverse lookup zone and see if it's configured correctly. We don't have any. Let's see if we have any forward lookup zone. As you can see here, we have a tpi.local. That's the parent zone that we have. So this is what we'll be servicing in our environment to make sure that everything works. Let's just say we wanted to add our host here. So let's go to our forward lookout zone, and we want to make sure that we are resolving the host properly. So we can come here and add an A record for our pfcns router. You see it says pfcns01.tpi.local. So we say the name. In this case, the name is pfcns01. That's the name of the machine that we want to resolve the name, and its IP address is 192.168.138.1. Let's create a PTR and also allow, just in case we add more, and add host. It was created successfully, done. So now we have a pfcns with an A record here, and it's going to be pfcns01. So now if I go to my browser and I go to http pfcns.tpi.local, let's see if we will be able to resolve that. There we go. So that's DNS in action. We know our DNS is working, because now we can access our pfcns not by its IP address, but by its host name. And we told it in DNS, and now it's here. And sure enough, we can now forget the IP address, and now every time we access our pfcns, we're just going to be using pfcns.tpi.local. That's how DNS works. Let's go and now configure our DHCP. Make sure that everything is good. So to configure our DHCP, it will show up here when it's done with everything. Configuration required, it will tell you right here. You can say more, give me more information. Complete DHCP configuration. Now we want the new host to point to this DNS server, and this machine to be the one that gives all the new machines IP addresses. That's all we're doing here. So now we can say next. And then we have TPI administrator, sure. However, before I completely disable DHCP, there's one thing that we need to keep in mind in our pfcns, right? Let's sign in here. Since we're accessing it using our DNS name, now we need to go to our pfcens and disable DHCP, but only on the interface that we need it disabled. So if I go to my interfaces, LAN, this is the interface that I want DHCP to be enabled. So if I go to my services, I just need to disable DHCP on that network. I don't want to disable on my storage net because my storage net, I'm still using it. So on my LAN, I disable DHCP. So LAN is no longer giving the IP addresses, but remember it was giving from 10 to 199. We'll put the same on our Windows server here. So let's save this. So there goes the feature. Now we can now say use the following credentials for administrator, and then we can commit. There we go. Now we can close. Let's see if he's happy. All right, so you can go here and also, like what we did for DNS, right click here, DHCP manager. Let's really specify what we want here to be sent to our clients. If you expand here, we're only working with IPv4. I want this to use tpi.local, so it's our DC02. We are interested in the scope. So if we come here, it says add scope. We can say add new scope. This is where we're going to specify the range of the IP addresses and the network that we're working with. The name, I'm going to name this one TPI-LAN. That's my main LAN interface. And next, start IP address. Remember from our pfcens, our start was this, 10 to 199. We're just going to do the same, 38.10.199. The reason why we're not allocating all of them is because our servers are going to have static IP addresses, and those static IP addresses, you don't want them to be issued by DHCP. That's why we're doing this. And our length is 24. So that's our range for our clients. So if you have IP addresses that you want to exclude, you can add them here. I already gave it a range excluding by default, so I don't need to exclude them here, but you can specify here if there's any IP addresses within that range that you specified that you wanted to be excluded. So let's just go ahead and leave that. This is then the least duration. This is when a client will release the IP address and request another one. Quick tip, if you're in a production environment, depending on how much traffic and how many clients you get, you probably don't want this to be 8 days. You want this to be hours, because if people bring their phones, you don't want people to go home with their 5 devices and hog IP addresses. So let's give these 8 hours, not 8 days. Minutes are too short, so 8 hours. And next, then you can configure DHCP options. Yes, let's go ahead and configure them. The IP address for the router used by clients, this is going to be the client's default gateway. We know our router is 192.168.38.1, right? You can add, that's our pfcens. If there was another router, this is where you add them. Usually enterprise environments have more here. And we say next. The parent domain is going to be tpi.local. That's what we want. To configure clients to use DNS servers on your network, enter the IP addresses of the servers here. Of course, we want them to use this server itself, so its IP address is going to be here, 192.168.30.200. If we have another backup, we'll add it. But so far, this is what we have. Then we leave it there. We're going to leave this one to the default. We're not going to change anything here. And I want to activate this scope right now and finish. And look what happens now. We have a DHCP server here. We disabled our DHCP from pfcens. Let's use this MacBook here to test our network connectivity and see if our DNS is actually working. To do that, I'll just go to my network preference here. It's connected to my lab called Howard's network. As you can see, it's connected on 192.168.38.20. I want to release this IP address and get a new one. So if I go to advanced, in my TCP here, it's set to DHCP. Let me remove this static DNS here so we can get it automatically. So on my TCP here on my Mac, if I want to test that my DHCP is working, let me release this lease. Then say renew lease and see what happens. All right, so now as you can see here, if I renew my IP address, it's going to give me 192.168.30.20. My DNS is set to this one. And if this worked correctly, if I go back to my DHCP server, I should now see clients here under my scope, lists. Let's see if my iMac is showing up here. Here's my address pool, address lists. Look at that. So my computer, my iMac just got a new list right here. As you can see, it's imac.tpi.local, and here's its IP address, which is consistent with what we saw in my Mac settings. So we can now tell that my iMac is connected to my DHCP. Our pfcns, the DNS name is resolving properly. So now all of our DNS for the lab is being controlled by our domain controller, and we have everything working. So that's what we needed to do here. And if you haven't and you have made it to the end, please subscribe for more. I know a lot of people watch my videos are not subscribed, so hit that thumbs up for me and also subscribe so that we can keep moving forward. Thank you for joining me. I'll be showing you more in the next video.